All right, so again, this is standard form. A is called the amplitude, right? The size of the wave. We know that that number there is like the radius of the circle. So A tells you how big the wave can be, because sine, we all know, can only go as big as 1 or as small as -1. So if we want a bigger wave, we got to multiply it by something, like the radius of a circle. So A is called the amplitude. B, in this case, is the period, which doesn't make any sense. Why should B be period? But they're trying to go A, B, C, D. Okay, so that's why B is a period. Because A makes sense. A for amplitude. So far, so good. But B for period. But whatever. So B is, wait. B is the period. Or B is the, sorry. I think B is the, no, B is the period. Not the frequency. So B is a period. In other words, B is how long is it between waves. So if here you have a wave, the period is the distance there. That's the period. How long is it between peaks? Or how long between troughs? Or how long between where it starts going up, it starts going up? But what is a full wave cycle? How long is that? Now it could be x, it could be a distance, the distance between peaks, or if it's time, it's the time between peaks. Many times it's time, but that's called the period. So like 5 seconds. So every 5 seconds a wave comes into shore or something like that. Okay, so that's B, the period. Then C is the phase shift. It's called the phase shift. And that is how far the wave is from a normal sine wave starts here. But again, maybe we don't want to start here and start going up. Maybe our wave starts right here. So the phase shift is that letter C. That tells you how far from the normal sine wave it is. So that would be C. How far from normal is it shifted to the right? And since C is minus, it's how far shifted to the right. Normally you just always shift it to the right. Keep it easy. You can shift it to the left a little bit or the right a lot. Sometimes it's easier to go plus to the left a little bit, but okay, so that's the phase shift, how far we shifted over from normal. And then D is the average. Normally the average is 0. If you don't put a D, the average is 0. Because it goes up from 0 and down below 0, up from 0. So normally the average is 0, right? We go around 0. Sine waves go from 1 to -1, 1 to -1, which is an average of 0. But if you don't want the average of 0, you add something to it. So D is the average value of your wave. And if you write it in that form, it's super easy to pick out all those numbers. Right away, you can graph it. You can see how big it is, what's the average, where is the start. So you can instantly graph it if you write it like this. But if it's like this, I don't know how to graph that. Now, I do know the average is 1. But so we want to try to write them all like that. And once you write it in that form, it makes more sense. You can pick out the things. Okay, so that's the idea. You always want to write it in that form. So let's do a hard one. I don't know. Let's do D. Okay, so now we don't have to do much. 5.6, that's good. But notice the 5.6 is multiplying the 12.12 because they put parentheses there. So we're going to have to multiply that out. So this is the same thing. So for D, it's 5.6 times the sine of, okay, we have 2/3 x. That does not look like 2 pi over b. Oh, and we want it to be x minus c. So we need to take out that 2/3. Yeah, okay, here's the tricky part. So we have a 2/3 times x. So we want to write everything in the front. So we have 2/3 times x. See, this, it's all in the front. X by itself minus some number. So we got to take a 2/3 out of the 7. This is the tricky part. So what do we multiply 2/3 by to get 7? You got to think back. I hate this. You got to think backwards, right? In other words, we take a 2/3 out of here. We got to take a 2/3 out of here. So wait, we turn this upside down, right? So it'd be 7 times 3/2.
Yeah.
Let's try that. See if that works. So we flip it upside down. Let's see if that works. That'd be 21/2. So x minus 21 halves. Now let's check that. 2/3 times x is 2/3 x. 2/3 of that, 2's cancel. 21 divided by 3 is minus 7. Yes, that works. So whatever you add in here, to take it out of there, you just flip it upside down. 3 halves. If there's a 2, it would be 1 half. And then always check. I find that a tricky thing to do. I always have to check to make sure I do it right. So this is the same thing as that. Now we close the parentheses. We have a double parenthesis here.
Oh, sorry.
And then, since this is in the parentheses, we got to multiply it. So we got to go 5.6 times 12.1, negative 12.1. So 5.6. I don't know if you can see that there. Okay. 5.6 times negative 12.1. I get 67.76. So minus 67.76. Since, again, it's multiplied by this, and then 5.6 is multiplied by that, too, because they add the parentheses. Okay, now we could graph that if we wanted to. The amplitude's 5.6, so it goes up 5.6 from the middle. The middle is negative 67.76. It goes above that by 5.6, below it by 5.6. Oh, wait, we're not done. Sorry, we're not done. One last step. We didn't write it as 2 pi over b. So this 2/3 has to look like 2 pi over b. So what is b to make that work? So that's the way you do that. First you do this step, take out the 2/3 and say, wait, that 2/3 has got to look like this. So how do we make 2/3 look like 2 pi over b? In other words, what must b be? Unfortunate. Let's cross multiply. So 2b equals 6 pi. Right? Cross multiply. 2 times b is 2b. 3 times 2 pi is 6 pi. Or b is 3 pi. So finally, and we want to write this then as 2 pi over b. So really this should be 2 pi over 3 pi. Now if you're really clever, you could have seen to do that. I'm not that clever, but I could have just put a pi here and a pi there and go, oh look, that's the same as 2 pi over 3 pi. But anyway, so you should replace this by that by just putting a pi in the top and the bottom. And again, check it out, right? 2 pi over 3 pi is 2/3. It's the same thing. But the point is, if we write it like this, we know that the period of this wave is 3 pi. A full cycle lasts 3 pi. If it's seconds, it's every 3 pi seconds a wave goes by. So even though it seems like more work, and it seems kind of crazy, why write 2/3 is 2 pi over 3 pi? It's because right away I can say, oh, the period of this wave is 3 pi. I don't have to think about it. And that's very useful. So I know that the period takes 3 pi seconds for a wave to go by. Okay, so even though it seems kind of crazy, it is a useful way to write it. Because then again, you can look at that form and go, oh, I know exactly what that wave is doing. All right, I hope they have the answers to all those in the back so you can check and do your work. But again, that's the idea with all of them. Now, a lot of it's easy, like the amplitude is obviously 11.2. The average is 8.3. The phase is 9.2. We just got to write here, we just got to write that as 2 pi over b. So you say 5 over pi is equal to 2 pi over b and figure out what b is, and then write it as 2 pi over b. So that's the only one wrong with that, only thing wrong with that one. Okay, everybody get the idea? That's called standard form because it's useful. You can read stuff off right away. You can read all the major things off right away. Did they say you got to graph these? That's a lot of graphs. No? Okay, good. All right, let's do a real problem then. How much time do we have? We have time. Let's do, I think I did, okay, on Canvas I posted some stuff. Let me see what I posted here. That's the wrong class. PreCalc, chapter 19, modules. All right, so I have 19.4 and 19.7. Okay, so I did 4 and 7. There should be videos of numbers 4 and 7. So let's look at a different one. Should we do number 2? Seems like a good place to start. I'll let you guys finish number 1. let's look at number 2. So it says, a weight is attached to a spring suspended from a beam. At time t equals 0, it's pulled down to a point 10 centimeters above the ground and released. After that, it bounces up and down between its minimum height of 10 and a maximum height of 26, and its height is a sinusoidal function of time, which it really is. If you pull, I got you set that up. If you pull something down a spring, let it go, right? It bounces up and down. Piece of elastic, whatever. So the idea is you pull this thing down, and then it goes up to, here's the ground. You pull it down so it's 10, a height of 10, and it goes all the way up to 26, and then it goes down to 10 again, goes down to 10 again, then up to 26, down to 10, and how long does it take? It first reaches a maximum height 0.6 seconds after starting. So this is time 0, so this is 6 seconds, it reaches its maximal height, 0.6 seconds. You let it go, you pull it down, let it go, bounces up to 26 in 0.6 seconds. What else do we know? Yeah, that's it, right? At time 0, we pull it down to 10, let it go, goes to 26, 0.60. Right here, we know this is 1.2 seconds. Every 0.6 seconds, it goes up 0.6, back down here, 1.2, back up at 1.6, at 1.8. If I get the idea? All right, now we want a formula for the wave. This is the height, right? We'll call it h. So the height as a function of time. That's what we want. We want an equation for it. Now, we can just, because we have the standard form, it makes it real easy. We can just write the answer. So awesome. So I'm going to turn this off. So, yeah.
So is the y equals a sine, that whole thing, is that the sinusoidal function?
Yes.
Oh, okay.
That's what we're going to use. So, but our y is now h. So here's what we do. We go h of t is equal to the amplitude. The amplitude is how high from the middle. Okay, so let's look at our picture. It starts at 10, goes to 26. What's the average of 10 and 26? Average, right? The middle. So you add them together and divide by 2, right? So, yeah, 10 plus 26 is equal to 36. Divide that by 2, yeah, is 18. So the average is 18. So D is 18. That's the average. It starts off at 10, goes to 26. On the average, it's at 18. And we know that the amplitude is always, okay, if the average is 18, how far below 18 and how far above 18 does it go? So it goes down to 10, which is 8 below and 8 above, right? Am I with me there? So I guess the range, you go, for the amplitude, you take the range, 26 minus 10, and divide that by 2. It goes up to 26, down to 10, so that's 16 divided by 2, which is 8. So it goes 8 up and 8 down, which means it's a range of 16. Makes sense? The amplitude is how far from the middle it goes. So, right away we know the amplitude is 8. 8 sine 2 pi. What's the period? How many seconds for a full cycle? And if we look at our picture, 0, 0.6 is up, a full cycle is backward, back to the start, so 1.2, right? So, a full cycle is 1.2, so put 1.2 in the bottom. And then we go time. Now the phase shift is the tricky one. Let's not worry about the phase shift yet. I'll call it C here. And we do know the average. The average we figured out was 18. So this is, again, a very handy thing, right? Right away we can write our formula for what this thing is doing. So let's make sense of this, right? What's the height going to be? The biggest this can be is 8 when sine is 1. So the biggest it can be is 26, which is right. The smallest it can be is when this is negative 8. Negative 8 plus 18 is 10. So that's right. The period is 1.2. It takes 1.2 seconds for a full cycle from down, up to back down. 0.6, 1.2. Now, what about the phase? The phase is always from the middle. A normal sine wave starts in the middle. A normal sine wave starts right here and goes up equally. But ours isn't starting in the middle. Ours is starting at a trough. We're starting at the bottom. Right, we're starting on the low point. So we are this far out of phase. Our sine wave is not cooperating with us. Okay, so basically we are not quite of a period. Okay, a full period is here to here. We are half a period and a fourth of a period. This is the tricky part. Everybody listening here? Okay, so what fraction of a period are we out of phase? Are we too far to the right? Right, we want to take our wave and we want to move this to, well, yeah, so this is our starting point. So our wave is too far to the right. Or, here's another thing, here's another way to think about it. This is a better way to think about it. When is our wave in the middle? This point, where is that point in our wave? So it's somewhere right here, right? It's in the middle. When is our wave at, well, what is the middle? We know that is the average at 18. It's at 18, halfway between 0 and 0.6, which is 0.3 seconds. Our wave starts at 0.3 seconds. So our wave is starting right here at 0.3 seconds. This is a better way to think about it. So let me go over that again. Sine waves always start at the average value. Ours is starting at the bottom, right? So when is ours at the average value? Well, ours is going up. If we're starting at the bottom, okay, we're like right here, it's going up, and it gets to the average, which is halfway up, at halfway in between the bottom and the top, which is at 0.3 seconds, because it takes 0.6 seconds to get from the bottom to the top, so it must take half that amount of time to get to the middle. So our phase shift is 0.3 seconds. Our phase shift happens, our wave is starting at 0.3, not at 0. So we want our wave to look like, let me make a different color. We want our wave to look like this. The middle, it's at the middle, right there, at 0.3 seconds going up. Middle going up at 0.3 seconds. So this is a normal one. We want to shift our normal wave over to the right by 0.3.
Oh, so then like our starting would be on the 0 or like?
Yeah, then our starting would be
On the line.
would be like our starting wave is down here.
Yeah.
Which is where it is, right? We're starting at the bottom. Our wave looks like this. We're starting at the bottom, which means we're taking our wave. Our normal wave starts here, and we're shifting it to 0.3. Therefore, it's starting down here.
So you're basically shifting it to where the start would line up with.
Right. You want to find where does it start going up. So our phase would be 0.3. And there's better ways to think about this, and we'll try to go over that. But I find the phase is the hardest one to come up with. Where does our wave start? Where does it, because remember the sine waves are always, they should start going up from the middle at 0. Ours starts going up from the middle at 0.3. Right here is the middle going up. So ours wave is too far to the right by 0.3. The way you shift things to the right is you take away, right? Negative 0.3 shifts to the right. Okay. Now we're done. Now we know what our wave is doing at any time we want. Isn't that awesome? We can say what our wave is doing now at any time we want. We know exactly where it's going to be at time 100 seconds. You just plug in 100, keep your calculator in radian mode, and you can solve for where the wave is at any time in the future. So again, this standard form is very useful. The trickiest part is the phase, and we'll do lots of examples. I think there's some better ways to explain that. Yeah, it's the hardest part. Okay, I don't know what else they ask here. They asked anything interesting. So that's, turn this back on. So what are the mean, amplitude, give 4 possible different start values for the phase shift, write down a formula for the function height and the standard sine form. Okay, we did basically all of it through E except for 4 possible values of the phase shift. Ah, they're making us think too hard. All right, so we know, we figured out the mean is the average. We did all this stuff already. We did A, B, C, D. When we wrote this down, we figured out the amplitude, the mean, which is the average, the phase shift, the period is 1.2 seconds. We did everything they said all the way to D except for 4 possible values of phase shift, so we got to work on that. We did D, write down the formula, so we did that. We kind of did all the way through. Now they're saying, what is the height of the wave after 0.18 seconds? So basically for E, you plug in 0.18 and it's a calculator problem. It's not easy. Make sure you have your calculator in radians. Calculator problem. F, during the first 10 seconds, how many times will the wave be exactly 22 centimeters above the floor?
Wait, sorry. Can you go, so for E, you would just input 0.18 into the T?
We put 0.18 here and are really careful with your pi's and parentheses and everything else. And they give you the answer, so it shouldn't be too bad.
So it would be H of 0.18?
Exactly. You'd say H of 0.18, you plug in 0.18, shouldn't be too bad. So that's easy.
Yes.
Oh, they don't give us a lot of, they just tell us the overall formula. Oh, which is what we got. Okay. So yeah, for their answers, all they gave us was the answer that I already wrote down up there. H of T is that. So we'll make sure that you get, I hate that when they don't give all the answers. Anyways, yeah, so for E, you plug in 0.18. Then they say during the first 10 seconds, how many times will the wave be exactly 22 centimeters above the floor? Oh my God, I don't know. So there's, right? So we know every 1.2 seconds, it goes a full cycle.
Is the answer 13.298?
For E?
Yeah.
They don't give us the answers in the book.
Does that sound right?
It sounds about right. It's a very possible answer, right? Wait. Do they say point, what, how many seconds do they say?
0.18. No,
Okay, wait, at 0.18. Oh yeah, I don't know. Yeah, because at 0.3 it's here. It's pretty close to 10. It's not quite in the middle, which is at 18 yet. So yeah, it's probably like 13 yet, because it's barely started, right? It's somewhere like right around in here, so in between 10 and 18. So 13 is about right. Sounds about right. Yeah, that sounds about right. Okay, we haven't done yet. Let's finish this problem off. They say during the first 10 seconds, how many times will the wave be exactly 22 centimeters above the floor? And then they say, note this problem. What about this problem?
does not require inverse trigonometry.
Oh, right. That's chapter 20 is when we do inverse trigonometry. All right, so let's think about this. This is where we got to draw a picture. By the way, drawing pictures of these is going to be critical. We have to be able to draw good, for chapter 20, it's like an art class. You have to be able to draw good pictures. All right, so let's draw our wave. So, the middle of it is at 18. So I can put 18 right here. It goes up to 26. So here's 26, goes down to 10. So here's 10. And the middle of it's going to be 18, so I'm going to put a dashed line down the middle of it. Let's see, it starts off at 10. The period is every 0.6 seconds something interesting happens. So let's do by 0.6. So here's 0.6, 1.2, 1.8, 2.4, 3, 3.6. I don't want to go all the way to 10. That would be painful. Let's go to one more, 4.2. They say in the first 10 seconds, but we can figure this out. We don't want to go to 10 seconds. Okay, so what's our wave look like? So it starts here. At 1.2, it's all the way back to there. Oh, I'm going to put another line. Here's what you want to do. You want to put lines at all the minimum and maximums. So you put a dashed line. Makes it a lot easier to draw. And then you put some dots in. Starts here at 0.6. That's when it's all the way at the top. 1.2, it's back at the bottom. So halfway in between, at 0.3, it's in the middle. So it's always in the middle. The middle ones are interesting too, but that's too much numbers to write. So it's in the middle there. 1.8 every 0.6. In the middle. So it looks like this is the bottom, so it looks like this. Continue here. 2.4. 3. Wait, the period's 1.2. 2.6. 3. I missed. It really helps to do the middle ones. I'm trying to cheat and not do the middle ones, and I missed. It's bad.
Can you draw it? Oh, okay.
You really need to put the middle ones in to get this right. Middle ones in. Okay, that's pretty good. Again, it really helps, I said that already, to put the middle ones in to hit those. So every 1.2 seconds, we start off at the bottom. 1.2 seconds later, we're at the bottom. 1.2 seconds later, we're at the bottom. 1.2 seconds later, we're at the bottom. Okay, my last one here is not so good. That should be the bottom of the curve. Right there. Okay, then it goes on and on and on and on. Forever! Except things don't go forever. Air resistance, they slow down. But we're not going to worry about that. Okay, we want to know, question number F says, after the first, how many times will it be 22 above the floor? Okay, 22, is it halfway between there? Or, yeah, it's halfway between. So I'm going to use a different color. By the way, it helps to have lots of different colors. Again, chapter 20, it's like crucial. Like drawing a good picture helps you get the problem. Do we get out of here soon? So what you do is you put a line here, and you say, okay, 1, 2, 3, 4, 5, 6, and how many if I kept going on? And you can kind of figure out the pattern, and you can kind of figure, okay, in 10 seconds, let's do 5 seconds, and then we just multiply by 2. I almost did 5 seconds. Or we could do 3.3 seconds.
It'll be like 11 or 12.
Yeah, look, in 3.3 seconds, I don't think we do that one. So we do 1, 2, 3, 4, 5. We multiply it by 3. Anyway, we'll have to continue this tomorrow. So,
Mr. Bassi, I'm actually understanding this.
awesome.